Good morning, Knights. Welcome back to Chemistry Online. So today we're going to work on the assignment that I gave you guys last class. I know I didn't work too many of these problems with you guys, and that's why today we're going to spend it mostly on working these problems. A lot of y'all did a great job turning them in, but y'all did very well without getting too much background information. Because my video was so long, it was 35 minutes, I didn't want to spend any time on this. It would have been a very long lesson. I didn't want to do that to you guys. So today I'm gonna solve through this entire thing, and then you're gonna get additional practice, and then that's gonna basically be it. And next class, we're gonna move on from electron configuration. So today's the last day we're gonna be working on this. So let's go ahead and get started on this. So first, it's asking for orbital notation, and I doubt anybody remembers what that is. So orbital notation, that's going to be the boxes with the arrows in them. So that's going to be 1. Let me see what it looks like when I use this one. All right, that's better. So that's going to be 1s, and then that's going to be 2s. And I have this chart right here just to show y'all what comes next. So after 2s, we go to 2p. And when we get to a 2p, those are going to be the 3 boxes that are attached to each other. So that's going to be our 2p box. And then after 2p, we have our 3s, which is just a single box. And then we have 3p, and 3p is the longer box, which has 3 in it. All right, so for carbon, first thing we're going to do is we're going to find carbon. Here's carbon right here. And carbon has a total of 6 protons, which means 6 electrons. And that's going to be 1 up arrow, 1 down arrow, 1 up arrow, 1 down arrow, 1 up, 1 up. And then that's going to be 2, 4, and then 6. So that's going to be our, so let me label this too. So that's going to be our 2p. That's going to be our orbital notation for carbon. So let's go ahead and get the next one. Next one we have is lithium. Lithium is much shorter, so it's got box 1, box 2, and it's got only 3 electrons. So that's going to be up arrow, down arrow, and then up arrow. That's our orbital notation for lithium. Next one is going to be chlorine. So chlorine is actually much larger. I can't see my periodic table very well. Let me pull it over here real quick. So as y'all can see, I don't know these off the top of my head, but chlorine has 17 protons, meaning 17 electrons. So we're going to go, here's our first box, our second, our third, hope that's enough. All right, so that's 2, 4, plus 6, that's 10, plus 2, 12, plus 6, yeah, that's enough. All right, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4, nope, shouldn't have done that one. That's 13, 14, 15, 16, and 17. That's going to be our orbital notation for chlorine. Next one we have is sulfur. Sulfur is going to be 1 less than chlorine. So basically we're going to need all the boxes that we have for chlorine. So that's 1, 2. Sorry if this is kind of slow. Good thing we don't have too many of these. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So as you can see, sulfur, which comes right before chlorine, here's sulfur, here's chlorine. So sulfur, which comes right before chlorine, basically has 1 less electron. That's the only difference when it comes to orbital notation and the full electron notation. Next section, it asks us for the full electron notation, which means we're not doing shorthand. It's going to be the entire electron notation. So let's go ahead and get potassium. Potassium is going to be K. K is right here. And I'm going to show y'all 2 ways of doing this. So over here, we have this chart. This chart, if you can draw it, and this is what I've made my students do in the past. So draw the chart it's very simple. So you start with the 1S's, start with the 2P's, 3D, and once you fill the chart, you're able to figure out which orbital is filled up next. Another way to do it is just to look at this thing. So let me talk about it on the periodic table. So our first, so this is going to be our 1S. Our next one, this right here, that's our 2S. And then starting at the 2S, that's where our 2P is. So this is 2P. So you're going to fill 1S. And this is also part of 1S, so don't worry about this one. After you fill 1S, you fill 2S. After you fill 2S, you fill 2P. And then we have 3S. And here we got our 3P. And then after our 3S, we got our 4S. And then after our 4S, this is our 3D. After 3D, we have our 4P, which is down here. So basically, you can use the periodic table to fill these out, or you could use off-Bell's chart. A lot of people prefer off-Bell's chart. It's a lot easier, but really, you need to have an actual understanding of the blocks. And we talked about it last time. So this is our S block, this is our P block, and then our transition metals, which are these right here, are going to be the D block, and then here at the bottom we have our F block. All right, so let's go ahead and get potassium. Potassium is right here, and we're going to start out with 1S. And because we fill our 1S, it's going to be 1S2. And then after our 1S2, it's going to be 2S2. After 2S2, we got 2P6. And then, like I told y'all before, first three always equal 10. And for potassium, we need a total of 19. So let's go ahead and get the next one. So after 2P, we have 3S2. And then after 3S2, we got 3P. And let's count what we have so far. So these are 10 plus 2 is 12. And we need 19, so let's add 6 more. So 3P6. And that gives us 12 plus 6 equals 18, so we're 1 electron short. After 3P, we have 4S, and that's going to be 4S1. And if you're wondering if you're right, all you need to do is look at where potassium is. So potassium is right here after the 4S, and this is going to be our 1, and then this is going to be our 2. So 4S1, 4S2. Potassium is right at 4S1. So our electron notation ends at 4S1. That's how we know it's correct. So next one we're going to do is magnesium. Magnesium is shorter, it's 12. And if we're going to do what we did last time, we should know that magnesium is going to end at 3S2 because it's right here at the 3S2 spot. So basically we're going to write out everything up to this point. So it's going to be 1S2, 2S2, 2P6, and then 3S2. And then that's going to equal out 12, which is the number of electrons that we need. So 12 here, then 19 here. And I'm going to keep writing out the number of electrons because it's important to know that these two things are, they come hand in hand. So next one we have is arsenic. Arsenic is going to be 33. So this one's much longer than potassium. And let's go ahead and get it. So it's going to be 1S2, 2S2, 2P6. So we're at 10 so far. And then 3S2, 3P6, 4S2. And then after 4S2, we have our entire D block, which is going to be 3D. So here, if we look at the chart, after 4S, we're at 3D. So 3D10. And that's going to give us 30. So now we're only 3 electrons short. And then that's going to put us at, so after 3D, we fill our 4P. So it's going to be 4P, and it's going to be the number of electrons we have left. So these are 10, these are 10, this is 10. So we're at 30, and then we need 3 more, so this is going to be 4P3. You add up the electrons, that gives you 33, which is the number we need for arsenic. All right, next one we have is sulfur. Sulfur is going to be 16. So let's go ahead and get it. That's going to be 1S2, 2S2, 2P6. So we're at 10 so far. We need 6 more. So after 2P6, we have 3S2. And then, so now we're at 12. We need 4 more. And it's going to be 3P4. And if we look at 3P4, so this is 1, this is 3, 3P1, 3P2, 3P3. 3p4 puts us right at sulfur. So that is correct. Next one we have is titanium. Titanium is going to be 22. So let's get it. 1s2, 2s2, 2p6, and we're at 10, and we need 22. So 3s2, 3p6, and then 4s2. That puts us at 20. We need 2 more. And then titanium is right here at, this is going to be 3d1, 3d2. Puts us at titanium. So 3d2. And that's it. Next one we have is antimony. Antimony is SB. SB is 51. This is going to be the longest one we have, so let's go ahead and get it. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then after 3d10 we have 4p6, and now we're at 36. After 4p6 we have, I'm going to put them down here, so 5s2. Antimony is here, so this is the 5s2. Then we have 4d10. And then after 4d10 we have our 5p3. And then let's add these up. So first 3 are 10, second 3 are 10, next one is 10, so that's 30, 36, 37, 38. 38 plus 10 gives us 48, plus 3 gives us 51. And for antimony, which is SB, we need 51. So that's correct. And that's it. Those are the full electron notations. Next, we're going to do our shorthand notations. So shorthand notations, they take much less time, a lot shorter. So let's go ahead and get to them. All right, so first one we have is going to be cesium. So cesium is this one right here, and I need a better look at my periodic table. And what we do when we do shorthand notation is we start off by writing out our noble gas that comes right before what we're dealing with. So in the case of cesium, the noble gas that comes right before it is going to be xenon. And we talked about this before, but basically, when we're doing electron notation, I'm going to clear this. It's too messy. So when we're doing electron notation, it's important to know that every element has all of the electrons that the element before it had. So when we use xenon over here, when we're doing electron notation for cesium, we're going to use xenon because everything that xenon has, every electron that xenon has, cesium has, plus 1 more. So for shorthand notation, we're going to start off with a bracket, and we're going to put Xe for xenon. So xenon has 54 valence electrons, and cesium has 55. So 54, and then all we're going to do is write out the remaining electrons that we need. We only need 1 more, so after xenon, it's going to be, so let me label these again. So that's going to be our 1s, that's going to be our 2s, 3s, 4s, 5s, and then 6s. That's where cesium is. So after xenon, we have 6s1. That's going to be our shorthand notation for cesium. Next one we have is bromine. Here's bromine right here. So the noble gas that comes before bromine is going to be argon. So here we're going to start off with brackets, Ar for argon. And then after argon, we have our 4s2. And then we have our 3d10. And then we have 4p5. And just to be sure, let's count up our electrons. So argon has 18. And I'm going to write it right here. I'll erase it in a second. So 18 plus 2, that's 20. Plus 10, that's 30. Plus 5, that's 35. Bromine has 35 electrons, which is what we needed. So there you go. Next one we have is going to be oxygen. Oxygen is right here. And this one doesn't really need shorthand notation just because it's so short anyway. But we're going to start off with helium. That's a terrible bracket. So helium. And then it's going to be 2s2. And then 2p4. So helium has 2 electrons plus 2, that's 4, plus 4, that's 8, which oxygen has 8. All right, for next one it wants is xenon. So xenon in shorthand notation is just going to be xenon. All right, next one we have is tin. Tin is going to be it's not SB, it's SN. So SN right here, that's tin. So for tin, we're going to use krypton. So Kr for krypton. And then after krypton, we got our 5s2. After 5s2, we got 4d10. And then after 4d10, we have 5p. That's going to be 5p1, 5p2. All right, let's add these up. So krypton has 36. I'll write it over here, 36. And then plus 2, that's 38. Plus 10, that's 48. Plus 2, that's 50. And 50 is what we need for SN. And that's it. So we just did all three. So orbital notation, full electron configuration, and shorthand configuration. Now I'm going to go through part of this. I don't really need to go through all of it because I don't need the video to be that long. So let's just go through a few of these. So barium, that's Ba. Barium is right over here. It's 56, right next to cesium. And first thing it wants is shorthand notation. So for shorthand notation, we're going to start off with our xenon. And then after xenon, we have 6s2. And that's it. That's shorthand configuration for barium. Next, it wants the period number. So this is going to be period 6. Then it wants valence electrons. So group 2 has 2 valence electrons. And then Lewis structure for barium, that's going to be Ba. And then it's going to have 2 electrons. That's it. So let's do the next one. So next one, it starts off with shorthand configuration, and we need to convert to regular. We need to figure out which element we're dealing with. So we have krypton, and krypton has 36 electrons. So 36. Plus we have 2, 10, and 4, which is 16. So 36 plus 16, that equals, carry the 1, so 52. And another way to do this is just look at the last thing. So 5p4, that's going to be, that's 2, 3, 4, 5. 1, 2, 3, 4. It's going to put us right at Te. So Te is going to be tellurium. That's not right. Yeah, it is. Tellurium. I'm just going to put Te. We don't need all this. All right, so for tellurium, it's got 52 52 electrons, which is correct. All right, so period number for Te, that's going to be, it's going to be period 5. And the way to know that is because it ends in 5. So period number is going to be 5. Number of valence electrons is going to be, so it's in column 6, which means it's got 6 valence electrons. And then for electron notation, it's going to be Te. And then 1, 2, 3, 4, 5, 6. That's it. All right, next one we have is aluminum. I'll do 2 more and then we'll move on. I'll do 2 more. No, I'll do 1 more. That's it, because y'all know how to do this. All right, so next we have aluminum. Aluminum has 13 valence electrons. I like to do that. So let's put in aluminum, and then for shorthand notation, it's going to be neon. So here's aluminum right here. So neon, and then 3s2, and then 2p1. No, it's 3p1, sorry. And then period number, that's going to be in period 3. Valence electrons, that's going to be 3. And then here it's going to look like this. All right, we'll do antimony, why not? Antimony is going to be SB, that's this one right here. So we're going to start with krypton. We did antimony before, so I'm going to copy it from here. Actually, I can't do that. So after krypton, we have 5s2. And then 4d10. And then 5p3. And if you're wondering if that's correct, all you do is count up your electrons. So krypton has 36. And then this is 2, 10, plus 3, so that's 15. So 36 plus 15, that gives us 51, which is what we were looking for. And then here we're going to put SB. So it's in period 5. And it's got 5 valence electrons. And then 5 valence electrons, that's going to be 1, 2, 3, 4, 5. All right, so I'm going to stop right there. If you guys have any questions, feel free to talk to your teacher. The substitute, she should be able to help you out with this. And that's going to be all from me.